Craftsmen have been setting tile for thousands of years. Over this time, their methods have evolved significantly. In much of the last century, tiles were set using the wet set method. Tiles were soaked in water prior to installation and set in a fresh mortar bed, using a mixture of Portland cement and water as the bond coat. Mortar, simply put, is a mixture of sand, cement, and water. There is a chemical reaction between the cement and the water called hydration that causes the mortar to set and harden. The same reaction occurred in the Portland cement paste used as the bond coat. Since tiles of the time were very absorptive, there was always a risk of them stealing water from the bond coat, preventing adequate hydration and causing a poor bond. Soaking the tiles before installation would prevent this from happening and allow for a solid bond between the tile and the mortar bed. The most fundamental change in the history of the tile industry came as a response to this need to soak the tiles. A new material was invented to take the place of the bond coat in this installation. This new material was a mixture of sand, cement, water, as well as a chemical additive that would retain water. This water retention agent prevented the bond coat from drying out too quickly, even when setting dry tiles. This is how the material came to be known as dry set mortar. While dry set mortar was originally intended to be used as a bond coat when installing tiles in a fresh mortar bed, tile setters began using it to bond tiles to cured mortar beds and even directly to concrete floors. This new approach reduced the thickness of the tile assembly and became known as the thin bed method. It also reduced the weight and cost of tile assemblies, leading to increased use of tile in a wider variety of applications. As tiles became denser, and since the substrates were still more absorptive and less stable than mortar beds, another type of bond coat was introduced. The latest material modified the existing dry set mortars by adding latex polymers to the mix. These modified dry set mortars had even greater water retention properties, as well as increased bond strength. In addition to cement hydration, modified dry set mortars need to dry out to allow the latex polymers to coalesce and form a hard film. Since most, if not all, tiles were installed over absorptive substrates, such as concrete, cement backerboard, and plywood, the mortar could dry quickly enough to set up in time for grouting the next day. However, as bonded membranes became popular underlayments for tile, the curing dynamic changed. The substrates would no longer absorb moisture, and the modified dry set mortars needed more time to dry out and set before grouting. The results could be unpredictable. This is why Schluter Systems began recommending only dry set mortar, also known as unmodified mortars, to be used to install tile over our membrane systems. Since the dry set mortars didn't need to dry out and actually benefited from the continued presence of water to hydrate the cement, the results were consistent and predictable. This approach was counter to the conventional wisdom in our industry that porcelain tiles must be installed with modified thin-set mortars, and led to some confusion. In an effort to eliminate confusion and provide a complete system to our clients, we decided to design and manufacture our own thin-set mortars for use with our membranes and boards. Now that Schluter thin-set mortars are available, why not make the simple choice and choose something specifically formulated for use with our systems? Schluter thin-set mortars. Now you're all set.